The Westinghouse ABB D4B Watthour meter is a 3-wire, single-phase meter. The connection diagram remains consistent regardless of the meter's current rating. For connecting power monitoring equipment to the rear connections of the meter, ensure you understand the terminal designations and wiring procedures. It is strongly recommended that a qualified electrician performs all wiring connections. Here's a breakdown of the terminals. Firstly, line terminal 1 alone. This is where you connect line 1, which is one of the hot wires from your power source. Secondly, line terminal 2 or L2. Connect line 2, the other hot wire, to this terminal. Thirdly, load terminal 1 or T-load. This terminal is connected to the neutral wire for load 1. Fourthly, load terminal 2 or TL2. This is connected to the neutral wire for load 2. Finally, the ground terminal or G. This terminal connects to the ground wire. Now let's talk about the wiring procedure. 1. Connect the line 1 or load terminal to the live wire from the power source. 2. Connect the line 2 or L2 terminal to the second live wire from the power source. 3. Connect the load 1 or T-load terminal to the neutral wire for load 1. 4. Connect the load 2 or TL2 terminal to the neutral wire for load 2. 5. Connect the ground or G terminal to the ground wire. Remember that this D4B meter is a 3-wire, single-phase meter configuration. This information and connection diagram are applicable irrespective of the current rating of the D4B meter. Safety is paramount when dealing with electrical wiring. If you are not a qualified electrician, you should not attempt these connections. Electricity can be dangerous, and improper wiring can lead to serious injury or property damage. Ensure the power is disconnected before starting any wiring work. Use appropriate safety gear, including insulated gloves and eye protection. Double-check all connections to ensure they are secure and properly insulated. If you are unsure about any aspect of the wiring process, consult with a qualified electrician. They will have the knowledge and experience to ensure the job is done safely and correctly. When connecting power monitoring equipment, consult the equipment's documentation for specific instructions on how to interface with the Watthour meter. Ensure that the power monitoring equipment is compatible with the voltage and current levels being measured by the meter. Carefully review the power monitoring equipment's specifications to avoid damage or inaccurate readings. In general, power monitoring equipment will require connections to measure voltage and current. The specific terminals used for these measurements will depend on the equipment's design. Refer to the equipment's manual for detailed instructions on which terminals to use and how to configure the equipment for proper operation. Keep in mind the importance of accurately measuring electrical parameters. Incorrect measurements can lead to incorrect billing, inefficient energy usage, or even equipment damage. Using calibrated and reliable power monitoring equipment will help ensure accurate readings. Routinely check the accuracy of your power monitoring equipment and recalibrate it as needed. Proper maintenance of electrical equipment, including Watthour meters and power monitoring devices, is essential for reliable and safe operation. Inspect wiring regularly for signs of damage or wear. Ensure that all connections are tight and free of corrosion. Keep the meter and monitoring equipment clean and free of dust and debris. Replace any damaged or worn components promptly. Following these guidelines will help ensure that your Westinghouse ABB D4B Watthour meter and power monitoring equipment function correctly and safely. Remember, if you are not comfortable working with electricity, always consult with a qualified electrician. They can provide expert assistance and ensure that all wiring is done safely and according to local electrical codes. It is important to reiterate that the D4B meter is a 3-wire, single-phase meter, and this particular wiring configuration applies specifically to this type of meter. If you are working with a different type of meter, such as a 4-wire meter or a 3-phase meter, the wiring diagram and terminal designations will be different. Consult the manufacturer's documentation for the specific meter you are working with to ensure proper wiring. Never assume that the wiring diagram for one type of meter will be the same for another. Different meter types have different internal configurations and require different wiring schemes. Using the wrong wiring diagram can lead to incorrect readings, equipment damage, or even electrical hazards. Additionally, it's important to understand the voltage and current ratings of the D4B meter and the power monitoring equipment you are connecting to it. The meter is designed to operate within a specific voltage and current range, and exceeding these limits can damage the meter or cause it to malfunction. Similarly, the power monitoring equipment has its own voltage and current ratings, and it's essential to ensure that these ratings are compatible with the meter's output. Connecting power monitoring equipment with incompatible voltage or current ratings can damage the equipment or result in inaccurate readings. Always check the specifications of both the meter and the power monitoring equipment before making any connections. In addition to voltage and current ratings, it's also important to consider the accuracy class of the D4B meter. The accuracy class indicates the level of accuracy that the meter is designed to provide. Higher accuracy classes indicate more precise measurements, while lower accuracy classes indicate less precise measurements. If you require highly accurate measurements for your power monitoring applications, it's important to choose a meter with a suitable accuracy class. The accuracy class of the meter is typically indicated in the meter's nameplate or in the manufacturer's documentation. When selecting power monitoring equipment, it's also important to consider its accuracy and resolution. The accuracy of the equipment indicates how closely its measurements match the true values, while the resolution indicates the smallest change in measurement that the equipment can detect. Higher accuracy and resolution are generally desirable, as they allow for more precise and detailed power monitoring. The accuracy and resolution of power monitoring equipment are typically specified in the equipment's documentation. Another important consideration is the type of communication interface used by the power monitoring equipment. Many modern power monitoring devices offer communication interfaces such as Ethernet, Wi-Fi, or serial ports, which allow them to transmit data to a central monitoring system. If you plan to integrate the power monitoring equipment into a larger system, it's important to choose equipment with a compatible communication interface. The communication interface and protocol supported by the power monitoring equipment are typically specified in the equipment's documentation. Furthermore, it's essential to follow all applicable electrical codes and regulations when wiring the D4B meter and connecting power monitoring equipment. Electrical codes are designed to ensure the safety of electrical installations and prevent electrical hazards. These codes specify requirements for wiring methods, grounding, overcurrent protection, and other aspects of electrical installations. It's important to be familiar with the electrical codes that apply in your area and to ensure that all wiring and connections comply with these codes. Local electrical inspectors can provide guidance on electrical code requirements and can inspect electrical installations to ensure compliance. Proper grounding is also critical for the safe and reliable operation of the D4B meter and the power monitoring equipment. Grounding provides a path for fault currents to flow back to the source, which helps to protect against electrical shock hazards. The ground wire should be properly sized and connected to a grounding electrode system that meets the requirements of the electrical code. The grounding electrode system typically consists of a ground rod or other grounding electrode that is buried in the earth. The ground wire from the meter and the power monitoring equipment should be connected to the grounding electrode system to ensure proper grounding. Overcurrent protection is another essential safety feature for electrical installations. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit. This helps to prevent damage to electrical equipment and reduce the risk of fire. The D4B meter and the power monitoring equipment should be protected by appropriately sized overcurrent protection devices. The size of the overcurrent protection devices should be determined based on the current ratings of the meter, the power monitoring equipment, and the wiring. In addition to safety considerations, it's also important to ensure that the wiring and connections are done neatly and professionally. Messy or poorly executed wiring can be difficult to troubleshoot and can increase the risk of electrical problems. Use appropriate wire connectors and terminal blocks to make secure and reliable connections. Route the wires neatly and securely, and avoid sharp bends or kinks. Label the wires and connections clearly to facilitate future maintenance and troubleshooting. By following these best practices, you can ensure that the wiring and connections are done correctly and safely. Finally, remember that working with electricity can be dangerous, and it's always best to err on the side of caution. If you are not comfortable working with electricity, or if you are unsure about any aspect of the wiring process, consult with a qualified electrician. They can provide expert assistance and ensure that all wiring is done safely and according to local electrical codes. Electricity is a powerful force, and it's important to treat it with respect. By following these guidelines and taking appropriate safety precautions, you can minimize the risk of electrical hazards and ensure the safe and reliable operation of your electrical equipment. Also, make sure that all connections are tightly and securely fastened. Loose connections can cause arcing, overheating, and potentially lead to fires. Check all connections periodically to ensure that they remain tight. It's also important to protect the meter and the power monitoring equipment from environmental factors such as moisture, dust, and extreme temperatures. Moisture can cause corrosion and damage to electrical components, while dust can interfere with the operation of the meter. Extreme temperatures can also affect the accuracy and reliability of the equipment. Install the meter and the power monitoring equipment in a location that is protected from these environmental factors. If the equipment must be installed in a harsh environment, consider using enclosures or other protective measures to shield it from the elements. Additionally, it's important to regularly inspect the meter and the power monitoring equipment for signs of damage or wear. Look for cracks, breaks, or other physical damage to the equipment. Check the wiring for signs of insulation damage or corrosion. If you find any damage or wear, replace the affected components promptly. Regular inspections and maintenance can help to prevent electrical problems and extend the lifespan of your equipment. When replacing components, always use parts that are compatible with the meter and the power monitoring equipment. Using incompatible parts can damage the equipment or cause it to malfunction. Refer to the manufacturer's documentation for a list of approved replacement parts. In addition to replacing damaged or worn components, it's also important to keep the meter and the power monitoring equipment clean. Dust and dirt can accumulate on the equipment and interfere with its operation. Use a soft cloth to wipe down the equipment regularly. Avoid using harsh chemicals or abrasive cleaners, as these can damage the equipment. Also, make sure to disconnect the power before cleaning the equipment to prevent electrical shock. Furthermore, it's important to keep the area around the meter and the power monitoring equipment clear of obstructions. Obstructions can block ventilation and cause the equipment to overheat. They can also make it difficult to access the equipment for maintenance or repairs. Keep the area around the equipment clear of boxes, furniture, and other objects that could obstruct airflow or access. Moreover, ensure you have the proper tools for the job. This would include insulated screwdrivers, wire strippers, and a multimeter. Using the right tools will make the job easier and safer. Always use insulated tools when working with electricity to protect yourself from electrical shock. A multimeter can be used to check voltages and currents to ensure that the wiring is correct and that the equipment is functioning properly. Finally, if you are unsure about any aspect of wiring or working with the D4B meter or power monitoring equipment, seek help from a qualified electrician. It is important to remember that electricity can be dangerous and that it is always best to err on the side of caution. A qualified electrician has the training and experience to safely and properly wire electrical equipment. They can also help you troubleshoot electrical problems and ensure that your electrical system is functioning safely and efficiently. Remember, safety should always be your first concern.